Welcome to Smart Academy. So today I'll take you through relative atomic mass and abundance isotopes. And please don't forget to subscribe and follow us on Facebook. The link is in the comment section. Please follow us, support us. That's the only way you can support us. Alright, so let's talk about the relative abundance before we go into the nitty-gritty stuff. So relative abundance. Relative abundance basically is just the percentage, or you can say a proportion of a specific isotope. Okay, just a percentage or a proportion of a specific isotope of an element that exists naturally compared to all other isotopes of that same element, yes. So you have understood that even though all atoms of the same element, they have the same number of protons, basically they have different number of neutrons, which is making them isotopes. So relative abundance tells you how common each isotope is in nature. So the key concept again is you understand what is an isotope. The same definition that you had at grade 12, an isotope, is an atom of the same element with identical atomic numbers, or rather protons, but different mass numbers, which is protons and neutrons. That's the mass number. Alright, so let me give you an example for you to understand better when you are talking about the relative atomic mass and the abundances. Okay, let's just have an example. And these examples, these are the questions that they can actually ask you to say, find this. Alright, so let's have an example. So let's say, okay, so what is the relative atomic mass of chlorine with the following composition. Okay, with the following composition. So we have, let's say we have 75.5% of chlorine atoms, okay, are chlorine 35, which is then we have 24.5%. Let's say we have 24.5% of chlorine atoms are chlorine 37. So of chlorine 37, I hope you understand what an isotope is by this time. An isotope, I said, atoms of the same element with identical atomic numbers, or protons, but different mass number, which is the composition of protons and neutrons, a mass number. Okay. Then when they tell you maybe to find the total abundance, that will be the sum of the relative abundances of all the natural isotopes of an element, and of which, of course, which must always be equal to 100%. In decimal form, we can say 1.0 in decimal form. Okay, so let's answer this question for you to understand this topic very well. So what is the relative atomic mass of chlorine with the following composition? So let's say we have 75.5% of chlorine atoms are, we have chlorine 35 for this, and 24.5% of chlorine atoms are chlorine 37. What is the relative atomic mass? So there we have the formulas. So I'll be erasing, so make sure you have a script where we'll be writing questions for you to revise after the video. Of course, you can come and watch the video again to understand better if you haven't understand at the first glance. So let's dive into the solution. So the formula is, so the relative atomic mass, okay, relative atomic mass will be, the formula is relative isotopic mass. So the relative isotopic mass, you multiply by the percent abundance. Okay, multiply by percent abundance, then plus another relative isotopic mass, you multiply by the percent abundance, then everything you divide by 100. So the percent, so you can write relative atomic mass for 1, this will be 2, okay, so that they will be different. So you have relative atomic mass for 1 and times percentage abundance for 1, then plus relative atomic mass for 2 times the percentage abundance for 2 as well. So this makes them different, okay. Alright, so that's the formula. So now, according to the data that we're having, so we have chlorine 35. So chlorine 35, that will be our so we can just plug in. So relative isotopic mass, that is chlorine 35, that will be our first isotopic mass, chlorine 35.5. okay, chlorine 35, sorry, it's just 35. So chlorine 35, so we're going to say chlorine 35 multiply 75.5%, okay, chlorine 35 multiplied by 35%. Then this, you had relative isotopic mass for 2, which will be 37. So chlorine 37, then you multiply percentage abundance for chlorine 37, which is 24.5. Then everything you divide 100, okay. So this is very simple and very interesting, okay. So the relative atomic mass, that will be if you multiply this, okay, let's see what we are going to get. All right, you can plug in the values and check what you're going to get. All right, so if I multiply 35 and 75.5, okay. All right, so for me, overall I'm getting 35.5 as my final answer. So this is the relative atomic mass. I hope you get the concept. Right, so let's have another question, how they phrase these questions on this topic. Let's have another one, another example here, okay. Let's say you have the atomic masses of the stable isotopes. So let's say the atomic masses of two okay, sorry, let me just write properly. The atomic masses of the two stable isotopes of boron. So we have boron, so we have 10, so this is boron, okay. We have 5 here. I hope you know the periodic table. Then you have 19 as the percent abundance, 19.78%, okay. And you have boron of 11 and 5 here. So here we have 80% as a percent abundance, 80.22%, okay. So 10.0129 atomic mass unit and 11.0093 atomic mass unit respectively, okay, respectively. So we have the atomic masses of the two stable isotopes of boron, which is 10, and the percent abundance is 19.78%. You can be writing this, and we have boron 11 here, the percent abundance of 80.22%, and these are the atomic mass unit. You have 10.0129 atomic mass unit and 11.0093 atomic mass unit respectively. Then the question is, calculate the average atomic mass of boron Calculate the average atomic mass of boron. Calculate the average atomic mass of boron. So before you even start answering the question, so you need to ask yourself, what is this average atomic mass? What is the average atomic mass? What is it? So the average atomic mass, so when you look at the periodic table, the value listed on the periodic table is weighted in average based on relative abundance, which is why atomic masses are rarely whole numbers. Okay, so that's the average atomic mass. You need to have this concept in your mind. All right, so I know you are from the 12th secondary level, so but you need to have updated periodic tables, because the updated ones, they have decimals. For example, carbon is 12 when on the secondary periodic table, but when you go to natural sciences, you'll find that it's 12.01, so you need to be using the updated one. Okay, so let's proceed. We find the average atomic mass now of what? Of boron. I hope you have now an idea. Okay, so the formula is, so let's write the formula first. So the solution, okay, solution. So the average atomic mass, okay, average atomic mass should be equal to, so the percent abundance for one, you multiply by the atomic mass unit, okay, you divide over 100, plus, it's very simple, percentage abundance 2, then you multiply with atomic mass unit 2, everything over 100. Okay, then you just need to plug in the values, then you get the answer like that. So let's plug in the values. So the percent abundance 1, so we're going to get boron having a percent abundance of 19.78 as our percent 1. So we're going to get here 19.78. so this will multiply 10.0129 atomic mass unit, everything over 100. Okay, then you plus 80, okay, 80.22, you multiply 11.009593, sorry. Okay, everything over 100. Okay, so when you calculate, when you plug in the values on your calculator, let's see what you're going to get. Let's see what we're going to get. Okay, all right, so we have 19, okay, 19.78 by 10.0129, so divide 100, so get for the first one you get 1.980, sorry, now 1.9817582, then this will add plus this one. Now we are on this one now, we can calculate this. So this one is going to give us let's see, so 80.22 multiply 11.00093 divide 100, so we are getting 8.3, so 8.83166046. okay, so when you add this, let's add, so this is 1.9817, so this is actually 10.81 atomic mass unit, so this is given us 10.81 atomic mass unit as our average atomic mass of boron. So this is our average atomic mass of boron. Okay, I hope you are able to understand. Okay, so let's have a different one. Let's have a different question. Alright, so this was an exam question. Okay, chemistry is interesting, guys. Alright, hope you guys are following. Okay, so this was an exam question, of course. Yeah, so the question was lithium has an elemental, okay, I hope you guys are able to see my handwriting. Okay, let me just write nicely. So lithium has elemental atomic mass of 6.941, okay, and has two naturally occurring isotopes. That is, so we have lithium 6, okay, and lithium 7. Their masses are 6.015, okay, 1, and 7.0160 respectively. Okay, respectively. Now the question is, calculate the percentage abundance of each isotope. So that's how they ask questions like this. You calculate the percentage abundance of each isotope. So lithium has an elemental atomic mass of 6.941 U and has two naturally occurring isotopes, that is lithium 6 and lithium 7, and their masses are 6.0151 and 7.0160 respectively. So they want us to calculate now the percentage abundance of each isotope. As simple as that. So here is the formula how to calculate this. So we're going to say RAM, relative, okay, relative atomic mass. We're going to have percent abundance 1 times mass 1, okay, then plus percent abundance 2 times mass 2, so over everything over 100. So this is the formula that we're going to use. Percentage abundance 1 times mass 1 plus percentage abundance 2 times mass 2, then everything over 100. Okay, so if you have noticed, what we have been given is, so we've been given this one, the RAM, which is the relative atomic mass. So this relative atomic mass have been given to be 6.941, okay, yes, and the percentage, since we're looking for a percentage abundance, we're going to say, so let the percentage abundance 1 be X. So we're going to say this will be X. So to be X, then we're going to multiply by the mass 1. So our mass 1 is actually 6, okay, which is 6.0151, okay, plus, so our percentage abundance 2, remember the percentage abundance is the average, the average or the total abundance is always equal to 100%. So we're going to say here, since we have X, we're going to say to be 100 minus X, you get, then everything you multiply by 7 by the mass 2, which is this one, 7.0160, you get, then everything you divide 100, okay. So it's just a matter of mathematics here. Yeah, you just find the value of x, just the issue of math to find the value of x. Okay, so let's find the value of x. Let's find the value of x together. Okay, so let's find the value of x. So this one, so here we can say it's over 1, so that when we cross multiply, we'll say 100 multiplied by this relative atomic mass. This actually will give us, if you multiply this, we'll get 694.1. Yeah, then when you expand the expression here on our right hand side, we're going to get so this is 6. Okay, so this will be 6.0151x. okay, then plus 01.6, then you minus so minus 7.0160x. okay, all right, so here we're going to do a subtraction. It's just a matter of correcting the like terms here. You know how to find these in math. Okay, you correct the like terms here, you correct the like terms. So we're going to get this and this to be on the left hand side. Okay, so we're going to say 694.1 minus 701.6 should be equal to 6.0151 x. okay, then minus 7.0160 x. So when you subtract this, so you get on our left hand side, on this part, on our left hand side, so this is our left, this is our right hand side. So on our left hand side here, you're going to get a negative 7.5. Here when you do a math, you get negative 1.00 another 9x. So when you divide this, okay, negative 1.0009. so our value of x, so just plug in on the calculator. So the value of x actually is giving me 7.5. so this 7.5, that will be the percentage. Yes, so meaning the percentage of lithium 6. So meaning, therefore, you can say therefore the percentage of lithium 6 actually is 7.5. Is 7.5%. If now you find the percentage of this lithium, what will be the percentage of lithium 7? Remember, the average or the total abundance is always equal to 100%. So meaning, for you to find for lithium 7 is now very much easy. So we're going to say 100 minus x. Our x value is now 7.5. okay, so we're going to say 100 minus 7.5. This should give you a 92.5. okay, 92.506, something like that. So when you land off this to the whole number, it will be 93%. okay, let me write nicely. So this will be 93%. yeah, so this is the percent abundance of lithium 7. Very simple. Let me give you something that let me give you a question for you, just to have a knowledge, or just to outweigh if you have understood these concepts today. All right, so let's have a question. The question is there's an exam question as well. So this question is let's have rubidium. Rubidium has 2 isotopes. Rubidium has 2 isotopes. Okay, rubidium has 2 isotopes. So we have 85. Okay, we have 85 RB and has mass of 84.9117 atomic mass unit, and 87 RB rubidium has mass of 86.9085 atomic mass unit. Okay, if the average atomic mass, so we have been given the average atomic mass. If the average atomic mass is actually 85.4678 atomic mass unit, now the question is, what is the abundance of each isotope? What is the abundance of each isotope? The formula is just the same. Okay, or the same formula. Just to give you the hint, the formula again is RAM being equal to relative isotopic mass 1, you multiply the abundance percent, then plus that. Okay, 2, you multiply the abundance 2 of everything over 100. Even the formula, just the formula alone, if you write the formula properly, they will give you something, a mark. Okay, so the answers you're supposed to get. So I want you to see the steps you're going to take, but the answer should be, for the first one, X value should give you 72.15%, and the second value should give you 27.85%. This is just to gauge your understanding on this topic. Make sure you just go through the steps and see if you're going to arrive at these solutions here. Okay, otherwise, thank you so much for your attention. Okay, see you in our next video.